All right, so continuing looking at scatter plots. I think in this question we're going to see kind of the value of what a scatter plot does. It says, is there a relationship between price and quality of athletic shoes? A lot of times we always think the higher the price, which is represented by our X value, the higher quality they are. So this is from Consumer Reports. That goes with our Y. Okay, so the quality rating goes from 0 to 100. I'm sure they had some standards on what meant for quality. We'll just put some trust into them. Okay, so they had 10 pairs of shoes here. The price we're going to say is our X values, and the quality rating is our Y values. Okay, so we're asking basically, remember, Y is dependent. Is the quality dependent on how much you pay for it? So one observation in the data set is 110.57. So right here, right? What does that mean in terms of cost and quality? So it means that if the shoes cost $110, the quality rating is 57. All right, so remember the quality rating is on a scale of 0 to 100, so a little more than, that's in the upper half, we'll say. Okay, so it says to construct a scatter plot of the data, you need to start thinking about the appropriate scales for the axes of the scatter plot. So the prices in the data set range from $30 to $110. So if you look here, you can see our lowest one is kind of here at 30, our highest one's here at 110. And then on the x-axis, it's going to range from $20. Nope, I'm sorry. So that's what they put the scale at the x-axis. When you scroll down here, you'll see it. So what would be a reasonable scale for the y-axis? So looking at our numbers here, I think our smallest number is 51, and our largest number, hopefully I'm getting this right, is 71, right? So we're going from 51 to 71. So notice they gave us a little bar break here. I'm not exactly sure why they did, because really they only skipped 10 numbers, but it's fine. I'm going to use that idea of a bar break over here too. And I'm going to put this in, okay? And then I'm going to go starting with 50, because it'll be on the left side of 51, and I'm going to go up to 75. So let's say I start I don't know, I'm going to start, oh, hard to tell the markings here. I'll start right here at 50, okay? And then I'm going to go 51, 52, 53, 54, 55. And then that's 60. Hopefully I didn't go too many there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 65. 1, 2, 3, 4, 5. 70. 1, 2, 3, 4, 5. 75. Okay. All right. So our price is our X values, our quality is our Y values. So just like before, we're going to take these ordered pairs, right? 65 and 71, 45, 45, and 70, okay? And let's put them on there. So I'm going to start with 65, 71. So 65 is going to be right here. Notice we have a little bar break here. And then 71. If I follow this up, there's 70 right here, and then here's 71. Okay, so I am going to pause it so I can put those on there so you guys don't have to see me squinting to try to figure out where they are. And I ask that you do the same. Pause your video, plot the points, and then see if they match up. All right, welcome back. So hopefully you guys got something like I have here. You can see at 110, there's a 51. Oh, what else was it? 57, 56, 57, somewhere in there. So paying 110, you can get a pretty decent jump in quality rating. But notice that our highest quality rating came down here. Second highest was at the 45, and then there was the 65. Okay, so the next question asks, do you see a pattern indicating there's a relationship? And I really don't. Now, I wonder if we would have not had these bar breaks in, if they would have looked more like they were linear or something. But really, these kind of seem all over the place. They're not showing us exact trend. So, I mean, kind of, but I'm just going to say not really. Okay. Not really. Okay, we can say, actually, it'd be more like as the price goes up, our quality almost seems to be going down, but not necessarily. So, therefore, my very scientific answer of not really. Okay, and we got to understand when we're looking at graphs, when we're looking at data like this, things like bar breaks, the scale, they can really, what we say, skew the data. They can make it look like there's a trend when there really isn't one. So you gotta be very careful when you're dealing with scatter plots, with statistics, because if we went by ones here, this might look a lot different. Okay, so always just be aware when you're reading graphs. And that kind of leads into this next part here. It says a pattern in a scatter plot, excuse me, indicates the values of one variable tend to vary in a predictable way as the values of the other variable change. This is called a statistical relationship. Okay, so there is kind of like a cause and effect thing going on. Fuel efficiency and car weight. Fuel efficiency tended to decrease as the car weight increased. This is useful information, but be careful not to jump to the conclusion that increasing weight of a car causes fuel efficiency to go down. There could be other examples. Heavier cars have bigger engines. Bigger engines are less efficient. So maybe it's not the weight of the car that's making it less efficient, it's the engine. You cannot conclude that changes to one variable cause change to other variable just because there's a statistical relationship in a scatter plot. That statistical relationship says, hey, there's something there we need to research, we need to study, but it doesn't necessarily mean that the one thing causes the other. And that's huge. Okay, that is huge because we can tend to believe it causes the other and jump to conclusions that or assume things that we shouldn't. Okay, so let's look at another example here. Data was collected on shoe size, our X value, and Y, your score on a reading ability test. Why would we do this? To prove a point. For 29 elementary school students. So the scatter plotted data is shown below. Does there appear to be a statistical relationship? Remember, statistical relationship means that one variable tends to vary in a predictable way. Okay, so as something's increasing, something's decreasing or also increasing, right? So does there appear to be a statistical relationship? And honestly, if we're comparing shoe size to reading score, it kind of starts to see that it's going up. I mean, our highest reading scores basically occurred with our largest shoe sizes. And over here, not necessarily our lowest, but our lowest came from a 5.5, and 5's the lowest. So does there appear to be a statistical relationship? Yes, there appears to be a relationship. Statistical, we'll just say relationship. Okay, but Mrs. Nelson, that's insane, right? That doesn't make sense. How we read is not affected by our shoe size. But according to this graph, remember when I said this about proving a point? It looks like it. Is there better reasons why that the reading score would be higher with a higher shoe size? Now we're talking about elementary school kids here. Us, for example, have elementary school kids preschool through 5th grade. Who has the biggest feet? The preschoolers or the 5th graders? 5th graders. Do you think 5th graders are going to read better than preschoolers or kindergartners, 1st graders? Yeah. So maybe it has nothing to do with their shoe size, but with the fact that they're older students who have had more practice reading. Okay. So a different explanation, I'm going to say larger shoe size usually means older students, and older students tend, not always, to read better. Not always, but they tend to read better. Why? Because they're older, because they've been practicing it longer, right? So be very careful. Later on you'll learn this shows like a correlation, but not necessarily a causation. There's some big terms you'll learn later on, because there does definitely seem to be a statistical relationship. But one variable in this case doesn't cause or necessarily cause the other variable, okay? Scatter plots and real life data, right? You get to make a lot of good decisions or hopefully good decisions, and you want to make sure you're taking the time to think about what graphs and scatter plots are showing you.